Hi, it's Jan Beta, and today I'm going to start restoration on what I think is at least one of, if not the, most interesting 68K Apple Macintosh computer, and that is this Macintosh Performa 630. This comes from a very generous donation from Markus, which I picked up. I also picked up several other things and little bits and machines that we're going to take a look at in other videos. This one I find particularly interesting because it looks like one of the classic Macintosh computers from the rather bland era that Apple had in the mid-90s. This is a Mac Performa 630, as I said, but what's special about this machine is this here, where it says DOS compatible. The Performa series was the budget version of Macintosh Quadras that Apple made at the time. The Performa 630 as well as the Quadra and the LC 630, all very similar. I think they mostly used the same mainboard, just different types of processors. This was first introduced in 1994. This particular version was introduced in 1995, the DOS-compatible version, which of course we're going to take a very close look into because that's what makes this interesting. This series of machines was introduced when Apple was just on the brink of making the step into the PowerPC generation of machines, and they actually released some PowerPC machines at the time while this was still in production. So this was a rather budget model at the time. These machines, the 630 machines, have a 68040 Motorola processor, so a classic 68K processor, the state-of-the-art 68K processor at the time, basically. You could also buy these Performa models with a TV tuner card, and that's what this little window is for. They came with a remote control, and this is an IR sensor there, which you could, I think, control the TV tuner card from, and also the music playback on the CD-ROM drives. The initial versions of these came without a CD-ROM drives, and there was a 630 CD version as well, so lots of varieties on this machine. They all came in the same case design, which we are of course going to take a look at. And the DOS compatible, which is the special thing about this version of the machine, which as I said was released a year after the introduction of this line of machines. That means it also has a full PC in here, and it is a 486 DX2 66 MHz PC on a separate card that sits on the Motorola CPU on the mainboard. And you could actually switch between the PC side and the Mac side, run them both at the same time, and just switch with a key combination. That feature probably makes this one of the most versatile retro computers today. Back in the day when this was released, probably the reason for putting a PC in here was that Apple feared that the IBM world would gain dominance over Apple, which it kind of did, at least at the time. This was shortly before Steve Jobs rejoined Apple and introduced the colorful third generation PowerPC, Macintosh iMac, and the clamshell iBooks and things like that, which kind of saved Apple from dwindling into oblivion. But this was from a time when they were still fearing that people would rather buy a PC than a Mac, which many did, according to the sales figures. But yeah, this has a 486 PC in here, and it should even be able to run Windows 95 with that 486. Pretty versatile machine. From today's standpoint, interesting in many other ways as well. It has a disk drive. It has a CD-ROM drive, which is not a super fast CD writer or anything like that. No DVD-ROM. This is a double-speed CD-ROM drive. This is going to be a series of videos because there's so much stuff that I found that you could do with this machine, modded in several ways, which are interesting. This also came with the 250 megabyte hard drive, which interestingly, while the CD-ROM is a SCSI drive, as Apple usually had in their machines, the hard disk is an IDE drive, and I'm not quite sure if that is a cost-saving measure because IDE drives were cheaper at the time, or if it has something to do with taking steps towards more PC compatibility. and compatibility with PC peripherals, basically. Not sure what that's about, but that makes this really handy because IDE drives these days are way, way easier to find than SCSI drives. I hope the CD-ROM still works because it's not going to be easy to find a SCSI CD-ROM. I think I might have one that maybe works, but yeah, these are getting rarer. And the disk drive, of course, is one of the ones that Apple typically used, which are pretty prone to failing, which has this electrical eject mechanism. Yeah, that might potentially be quite painful to restore. We're going to see about that. This is going to be a series of videos because there's so many things that I found during my research about this machine. Many things that you can mod and make a little bit better and try out that are related to the hardware that I want to do. I also, of course, as you can see, this case looks pretty yellowed and there's also quite some staining on here. That's going to be an episode, and today's episode is mostly going to be bringing this to a state where it's actually safe to power on. This machine does power up. I actually tried that when I picked it up at Marcus's place. It displays the startup, it chimes for the startup, which these Apples do, and it displays the picture with the mouse pointer that you can move, but it doesn't see the hard disk, so it doesn't boot up. It might be that the hard disk just doesn't have any system on it. I don't know. Otherwise, I didn't test anything, obviously, because we didn't boot it up fully, and it's probably a good idea to not run this in this state, but I'm going to try to bring it to a state where I feel comfortable running this for some time and working on it today. So let's dive in. Let me take a couple of seconds to thank the sponsor for this video, which is PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do 3D printing, sheet metal fabrication, CNC machining. They offer a lot of services that are super useful for the hobbyist or the professional tinkerer. I highly recommend them. Their service is exquisite, the quality of the products is excellent, and the delivery is super quick. So check out the link in the video description in case you're interested. Back to the Mac. This has several problems, unfortunately, as I have found out during my research, digging through some forums and things like that. These have power supplies that are not very reliable. Most forum posts I found where people had issues with these machines were because of broken power supplies, and specifically the capacitors in the power supplies blow up because some claim it is kind of too small for the machine to power it. I'm not quite sure. It might be an issue with cooling, which would be typical Apple behavior at the time. There's a fan in here, one fan for the whole system that cools the processor and the power supply and things like that. So there's not a lot of airflow happening. And the other issue that these potentially have is that the mainboard, of course, has the dreadful SMD electrolytic capacitors on there that were not really good in the 90s. I think it's not quite as bad as the slightly earlier Amigas and things like that that I worked on in previous videos, but they probably need to go and be replaced. Yeah, that's pretty much what I want to tackle today. Replace the capacitors, take a general look at the machine, replace the capacitors in both the power supply and on the main board, and then try to power this on and see if it runs at least halfway. So that's the plan for today. Let's dive in, finally. The case design is super nice because you can access a lot of things, including the mainboard, with just minimal effort, because the mainboard is just in a drawer, kind of. You're going to see. There's two screws here that we need to remove. Oh, another problem with these machines from that era in general is that they might have really brittle plastics. We didn't even have to remove this, but I'm going to have to remove everything anyway. So this just unlocks here. There are two little tabs that I need to push down. And then we have the drawer where our mainboard is in, and there's two screws I have to remove. You can remove this door here without removing the top part here, but we're going to have to take this apart a bit further anyway, so that's not going to hurt. So the thing is, there's two screws here and here that you can remove, and then you can get the mainboard out of this by just bending this little handle and then pulling it out. So now you just pull on this and this just slides out. And that's the whole computer basically, the main board. 68LC040. This is the version without the FPU. The higher tier models of the series had a full 68 or 40 in there, but the Performa only has the LC, which is lacking the floating point unit. But this is still pretty capable processor for the time. It says 1994 here, as I said, around that time. I think this version was released in 1995. This was designed in 1994. This board here is actually the PC board, and it sits in the processor socket for this processor, which is usually in the center here, and moves it to the side. And there's just a connector on here that plugs into the real main board. This is our 486 processor and some supporting chips for the PC side. And interestingly, this also comes with a separate sound card for the PC side, which is a standard Sound Blaster card, I believe. I think that's this little fella here. This here, another card, is the game port. The sound card is actually connected to a PC compatible game port. 15-pin D-sub connector here that can connect to a PC joystick just as you would on a regular PC. Interestingly, the RAM for the Mac side of things is here. I think both of these slots are RAM, whereas one slot can take single or double banked RAM. This is double banked, it has RAM chips on both sides, and the other one can only take single banked RAM, which is the other stick here. Don't know exactly how much RAM this system has in it. I think it has 4 megabytes on the mainboard, soldered on the mainboard, and then you could expand it through these two slots to up to 52 megabytes of RAM, I think. And the PC side has its own RAM slot here. These are just DRAM SIMs, just the standard DRAM sticks that you would find at the time. And fortunately, on this particular machine, the battery, which usually sits here to power the battery-backed clock and things like that, that was already removed. These things can leak, which is another problem that these machines have. And this is just kind of velcroed on here. It's just a little black block that has a 4.5 volts rechargeable battery and connects to this connector here. And we're going to leave it out for now and possibly make a new one at some point. And you can also already see these electrolytic caps that are on here. They do look good. There doesn't seem to be any leakage here, just a bit of dust. I think what I want to do as my first step is to remove everything from the mainboard and replace the electrolytic capacitors on here with fresh ones, good brand, Panasonic I think is what I have. These are just a couple of 47 microfarad ones and I think a couple of 100 microfarad ones, if I'm not mistaken. We're going to take a look. I'm going to be super careful with this machine, but this one in particular because it's quite a rare machine these days, I believe. This is a RAM stick from 1994. And I think this is the video in slot. I think this is where the TV tuner card would go. There's another communication slot here, which looks like a PCI slot, but I don't think it is a PCI slot. And there is the usual, I think new bus is what it's called, the usual slot here for Macs of that era. So this is the other RAM stick for the Mac side, and this is the one for the PC side. And there's a couple of screws securing all these cards in place, which I'm going to remove, and these connectors. So let's remove these screws here. I think we'll start with this probably. There's standoffs and they're screwed down through the standoffs, the circuit boards. Yep, this is one of these connectors. And this, yeah, that's kind of neat. That's a Sound Blaster 16 chip of some description, Vibra 16. And this is also interesting for retro gaming stuff. It has a real Yamaha OPL chip in there. This is a YMF262, if I read that correctly. So this is a fully fledged sound card, like you would have in your PC, used for the PC side of this Mac. I love this already. Oh, okay, that was easier than I thought. This is our PC card. Interesting. Pretty standard PC stuff. And it looks in really good condition, so hopefully this is going to work. This is a beautiful ceramic package, 486 as well. So yeah, we are going to store this somewhere safe. No electrolytic SMD capacitors on there, thankfully. This probably screws in. Yeah, we have to remove some screws on the connector here. Okay, the screws are all very tightly in there, which is, as I said repeatedly, kind of a good sign. So they tensioned them enough to still be in there. I don't think this has ever been taken apart to that extent. And now we should be able to pull this card out in some way or the other from this new bus. I believe I'm not an expert on Apples of this era. This is actually the newest Apple I've ever shown on the, except for my modern day MacBook, newest Apple I've ever shown on the channel probably. So yeah, this is the, I think it's NuBus, does it say? LCPDS slot, so it's a different kind of NuBus. They had all kinds of different connectors there. So NuBus doesn't have this break, I think, in the connector, if I remember correctly. But this is just basically just the game port and a controller chip that identifies the expansion, I think. So this chip just tells the system that the PC card is in there and how to handle it. Basically a hardware driver chip, if you want. I think this is just the connection for the game port, basically, this cable, and the expansion is identified through the expansion slot here. So yeah, you can't really use any other expansions in here except for this slot here, which I think there's a network card for this, which is of course super rare these days, and the TV tuner card, which is also rare, aside from getting it with the matching system. Yeah, I think this gives me enough room to replace all the electrolytic capacitors on here. By the way, this has some clips on here that are used as grounding clips, I believe. These things here and these things that clip through the top side, they are used to connect the grounds in this system to the case, and also the grounds, the separate grounds on the mainboard itself, I believe. Yeah, and as I said, we have some 100 microfarad ones and some 47 microfarad ones here. 47 microfarads 16 volts and 100 microfarads 6.3 volts, which are really standard electrolytic SMD caps. So I have those in my parts bin. I think my voltage ratings are a bit higher, but as long as we get the capacitance rating correct, that should not be an issue, and in fact should be a bit longer lasting than these ones. These ones are from the 90s, so they're probably no good anyway, but I'm going to replace them with slightly higher voltage ratings is what I have in my parts bin. The dimensions should be alright, and they are not that crucial for these SMD electrolytic capacitors anyway. They fit the footprints fine most of the times. So yeah, I'm going to desolder these with hot air, which is my preferred method. Of course, there's other methods that work. I personally don't like the twist off method or the cutting the metal can off method because they put a lot of stress on the mainboard. There is no real ideal way of doing this, but I found that hot air works in the least destructive way. It is a bit slower than the other methods. Using hot tweezers seems to be a good method, but I didn't try that yet. So I'm just going with hot air, which is my personal tried and known to be working reasonably well method. I am going to mask off some of the plastic components and other components around the capacitors with Kapton tape, which is a heat-resistant tape that prevents these from getting too much heat and prevents the smaller components here from accidentally getting desoldered. There are some parts here where it's pretty close to these connectors, which I don't want to melt. So I'm just going to mask this off at this point and then use hot air to desolder all these. I am going to link a website that I found, I think Recap a Mac, in the description that shows you where the capacitors go. I've done this a lot on Amigas and things like that, so I'm pretty confident that it is going to work fine. Not going to go into great detail about this because I already did a lot of videos about this process. This is the onboard RAM, it seems, which is pretty interesting. I think this might just be 4 megabytes, as I said. I'm sure you're going to correct me if I'm wrong about that. So just some tape on the components surrounding our capacitors to protect them. I think I covered everything that I need to cover. I'm using a relatively small nozzle on my hot air station, so my aim should be relatively good. Didn't have to go berserk with the Kapton tape there. Just the little components. There's a couple of very small components here, these resistors and capacitors, and there are some close to the SMD electrolytic capacitors. And I'm also protecting the chips and things like that, like here, to not overheat. I'm going to add some flux to all of this and remove them with my hot air station. There doesn't appear to be any leakage at this point, which is cool. So the way I do this is to heat them up. The solder joints, of course, not the capacitor itself. These can pop if you heat them up too much. I'm just heating the solder joints on both sides, taking turns, and using a pair of tweezers to try and see if they are already coming loose, and usually takes a moment. Huh. Yeah, but that's the way you do it. I just forgot to add some flux, which usually makes things a bit easier. Just adding a bit of flux. There's not too many capacitors on here, thankfully. So yeah, let's go on and desolder these. They literally just fall off if you heated them enough. You don't want to use any force. So if they are loose, they are loose. You're going to notice just by touching them, basically. There we go. So you don't need any force to remove them if you do this correctly. By the way, this is the hot air station. I use an 858D clone by UV Star. These are available under a number of different brand names. I have set it up to full airflow and 370 degrees Celsius. That is the setting that worked best for me, but your mileage may vary on these, and these probably are not calibrated correctly from factory, given the fact that they are just, I think, 30 euros or something like that. Yeah, that's all my SMD electrolytic capacitors removed. Some of them came apart a bit, which probably is because I heated the electrolyte so much, but it also shows that these were maybe not very good anymore. I'm going to clean the pads with some solder wick and my regular soldering iron carefully to be able to put new solder on there and don't mix it with the old stuff that was used from factory. And to solder these in, I'm just using my regular soldering iron as well, and regular solder with lead in it, because it's easier to work with in my experience. Then I'm just using some IPA cotton buds, cotton swabs to clean the areas there of flux residue and things like that, and possible leakage, but I don't see any signs of that. So I have the website open here on my more modern Mac. Slightly, ever so slightly more modern. Yeah, and I'm just going to put flux on all the pads now, because I tend to forget to put flux on there, which makes things considerably easier. We're going to start with these, and I'm just going to put them on there after tinning one of the pads. Yeah, and these are a bit larger than the original ones, but they fit fine. The footprints for these are not very different. It all looks pretty good, I would say. Just going to double check the polarities with my plan here, but so far I can't see anything wrong. everything looks good to me. On to the next thing, which is the power supply, which, as I said, some people in forums posted pictures of exploded ones. I hope this doesn't look so bad. We're going to have to extract it from the computer, though that might be kind of an issue. We're going to see. So this case is actually pretty neat in some respects. The plastic is notoriously brittle on these older Macintosh machines, but you can actually access the drives without taking it fully apart as well. The front plate should come off. There's two little tabs, one here and one here, that you can just push up with a screwdriver. I'm using a plastic spudger tool here to try and minimize damage. Yeah. Pushing these up, and then you can take the front plate off, which has some extra shielding here. Pretty nice. And we can take a look at the drives, which should also be removable. The hard disk drive is underneath here. So this is what this looks like. This flap here, there's one screw here that you have to remove, then you can take this out, and the hard disk connectors are actually on this side here. We don't have to remove those, I don't think, but we can pull the top part of the plastic towards us from this perspective and then lift it up, in theory. Yeah, there we go. That's the top part removed, and we didn't break any plastic yet. I think we might even be able to remove the side panels. Yep, they just slide to the front and lift off. Okay. So good thing we removed this bezel on the back here unnecessarily at that point, but now it makes sense. There's two screws here that probably hold the whole metal thing here in place. The fan is pretty dusty. It's a 12-volt fan. Maybe we're going to replace that with something better. But as I said, yeah, this is going to be an ongoing project for quite a while, I guess, because there's so many things I want to try. Power supply should be here somewhere. Let's have a look. So this should now slide out towards the front, maybe? Does it? Yep, it does. And we should be able to lift this up. Yes, this is the power supply. Just going to unplug this. This should just come apart. There we go. Okay, and then there's another little connector here for the fan that we could potentially pull out. And a connector for some signals, it seems. Yo, that pulls out. Okay, and now there's a screw there. That might be the one that we need to remove to get this loose. So down there, that's our screw. I think that might be the one that holds the whole thing. Let's see. Ah, it's connected to this here. We need to remove this whole thing. I think we can take the whole bezel out here, maybe. Ah, okay, this just lifts out at this point. Okay. So this whole back part here just lifts away, and I'm just going to put it here because there are some cables. And now, this whole thing, yeah, this just comes out. Okay, that was relatively easy, if you know what you're doing. Yeah, there's several screws here that probably hold the heat sinks in place. And there's a couple of screws here. We want to get to the circuit board. So we have to remove this here to get to the screws on the circuit board. Two screws. Does this come apart? Yep. Clipped in. And this seems to be an Aztec power supply, model number AA19300 6140037. Do not remove cover, no serviceable parts inside. Haha, you bet. Yeah, so this is what this looks like. This is a pretty standard switching power supply of the era. And as you can see, there's some brown spot here around this resistor here. And I think especially these smaller ones here, the C40, that feels pretty loose. And these smaller capacitors here have a tendency to start to bulge And these are glued together here with some kind of hot glue that turned orange, interestingly. So yeah, let me just get this board out here, I guess. We might have to desolder the wires on this mains connection. Yeah, we need to remove these screws here for the heat sinks and the screws on the board, it seems. And there's a cable tie here that we have to cut. The connector here is connected with the cable tie. Was connected. This looks rather neat, actually. I don't think this is badly designed. Maybe it's a bit underpowered for the system. This is pretty nicely screwed down, which is, of course, a good thing. Pretty well built, actually. So, yeah, we have to remove these screws here on the side for the heat sinks. We only have to remove these. It seems the other one doesn't screw to the case, just to the heatsink. And the transistor that's connected there, or voltage regulator. Yeah, this is now loose, but we kind of can't remove it yet. Okay, I think we have to remove these wires here. Desolder them. Okay, that's wound through that's properly built, and it's wound through the connectors there. So that one's off, and I melted some insulation there. That's not pretty. How do I get to that with my soldering iron without damaging the whole thing? It's a very tight fit as well. Okay, so I managed to get the board out with one of these mains wires removed. Going to try to remove the other one as well. I'm going to put longer wires in there to make it easier to work on this in the future. I think what I want to do is to mark all these. Most of them already have like a red dot on there, and I'm just going to put red markings on all the other ones, so I know which ones are the old ones. The old ones are the ones with the red dot. Quite a few capacitors in there, as usual. This bulk of capacitors, and there's one under here, which is also going to get a red mark. Kind of a bit of work to do. There's actually two under here. And I found a website about recapping this as well, or rather a forum post, which I'm also going to link in the video description, which could be useful. It seems to be the same model as well. So I might have to order some capacitors for this, but I'm at least going to replace the smaller ones, which seem to be the main culprits for this breaking down or exploding. So these smaller ones start to leak and explode, probably especially this one, because it's so close to where it gets really hot, as witnessed by the scorch marks on the board there. And you can also see some burned stuff on the back here. And there's some corrosion actually happening. There's some green stuff here. Can you see that? Now you can probably see better. There's some green stuff around here. And that's exactly where this resistor and this capacitor are. Maybe this capacitor already has leaked. Can't see anything from the top side, but there's definitely something going on the bottom there. So yeah, it might be a good idea to recap this fully, but I'm not sure if I have all the values in stock. So maybe we are going to have to revisit. And in the forum post I found, and that I'm going to link, there are part numbers for the correct dimensions and things of these, and the dimensions of the caps. It all looks rather nice, except for that burned spot there. And there's no heatsink plaster on here, but there are these silicon heat conductive mats, which is a nice touch. Don't have to replace any heatsink compound, I don't think. Yeah, there's pads under everything. It's actually quite a nice power supply, from what I can tell. I'm not an expert at all with power supplies, but does look really well made. And Aztec was no small name in the business, I believe. Yeah, I'm going to try to clean this up with some alcohol at first, I guess, so I can see what's going on maybe. Some green stuff on there. And it smells a bit like capacitor leakage. So we might very well have a time bomb here with that capacitor. There seems to be some trace damage even, or at least the solder mask is a bit corroded there. There's some solder mask missing around these. And this is, yeah, that might be the resistor. But right next to it is the capacitor. So maybe there's some leakage there. Or this just happened because of the heat. That might also be a problem from that resistor. Definitely going to check that resistor, but it's probably still good. These things are, the green ones are, I think, metal oxide. I think this is a metal oxide resistor, and these usually can take a lot of heat before they even start breaking. So I have my desoldering station powered up, and I'm at least going to desolder this capacitor here. Yeah, that looks leaky. Look at that. That definitely looks a bit compromised on the bottom. So yeah, I'm going to clean the area there. There's also some green stuff on that diode there. Going to have to do some cleaning on that with some IPA. We might just have caught this just in time before it did some damage to the system. As I said, this powered on and showed a mouse pointer and stuff like that, at least. So that is a sign for this power supply maybe not being completely broken yet. And there's ways to replace these with modern PC power supplies. That's a whole different can of worms. Because you have to fit it in the original casing basically. Okay, that diode actually looks good, that's cool. There's just some surface green stuff on there. Yeah, most of it just leaked on the backside here. That's where the green stuff happens. Yeah, I'm just going to put a new 22 microfarad capacitor in there and check the other ones. Yeah, that was leaky. That definitely was leaky. Everything points to it. That's of course not very good. But hey, we caught this in time. We're going to desolder the other components there. And clean the pads up before we put that back in. That's our resistor, I believe. The resistor itself actually looks really good, but there's some burning on the board. There definitely was a bit of corrosion going on there that we need to clean up. I think I just want to use my glass fiber pen here and measure the resistor. Okay, that cleans up quite nicely. At least, that's good. Might even put some new solder mask on that. Yeah, I didn't expect that something would be that leaky already. And it at least started eating the solder mask, which doesn't look nice, but it's not as bad as compromised traces, so we don't have to do any trace repairs that I can see. Let's measure the resistor here. That's like 148, so that's probably 150 ohms resistor. I'm not sure about the value. Color codes might be different for the metal oxidized stuff, but this seems to be a 150 or 147 ohm resistor here. That's still good. And it doesn't look compromised at all, so that's good. At least that works. So yeah, I'm just going to put the resistor back. I think the other pads look rather nice. Now for the one that I found to have cracked solder joints, I'm just going to pull that as well. And that's a 47 microfarad one. We have a replacement for that, I'm sure. Okay, so these are the ones I think were the problem in most cases. There's another small one down there. There's some corrosion here as well, so these have leaked as well. Uh-oh. You can see in this spot here, there's some more corrosion going on that's dull. And there's our small capacitor. Yeah, there's definitely something going on there. And we at least have to replace the smaller one there. It's not quite as bad as in this region here. Probably here the heat played a huge part to speed up the corrosion. Yeah, and as soon as you have corrosion, it's not so easy to desolder these things. Some flux might help, some fresh solder might help, some cleaning up of the corrosion might help. This sucks. This is a 10 microfarad one. Yeah, there's some bubbling going on there on the solder mask as well, so I'm going to use my glass fiber pen to free that and then clean it with some more IPA. And I'm going to have to replace the solder mask, so maybe this video is mainly about recapping the mainboard and we're not going to power this on after all, because with this power supply I'm pretty sure there's more capacitors on the brink of leaking in here. These are the worst ones that already have leaked, but the other ones probably are not that great. Yeah, this could potentially be a whole different video. Yeah, I guess I'm going to replace that one with a 10 microfarad one, but I'm not sure if I want to power this on. I have some of the values, but they have like strange form factors that I don't have. There are some of these taller ones, smaller diameter taller ones that I don't really have in my parts bin. This one as well. Yeah, I think here's what I'm going to do. I'm going to order the capacitors, the correct sizes, physical sizes, and then recap this completely before I dare pouring this on again. I mean, we had it running, but maybe that wasn't the brightest idea. Hope nothing else got damaged. But I mean, it ran, it worked fine. I think it took a minute before it actually booted up, which would be an indication for the capacitors trying to work and charging up, but not charging up as they normally would. Yeah, so I think we are not going to power this on after all in this video. There's going to be another video about working on this power supply. We could try using this like as it is, but I'd rather not really. I'm not sure if I want to power this on. I don't trust this thing at all. So this video ends right here. At least I recapped the main board. Can't test if this recapping effort was crowned by success. But yeah, with this I don't really want to try my luck. Hope you understand. And hope this was an informative video nonetheless. I announced that this would be a longer term project, so probably, maybe, I don't know when the capacitors are going to arrive. I'm going to order them right away, and then we're going to continue working on this. Maybe there's another video in between, probably even, but yeah, I'm not going to risk damaging this nice machine with this. Yeah, so I guess that's it for today. Sorry that I didn't show you this machine powering up, but I hope you understand the reasons why I won't risk doing that. Just want to make sure that this power supply works properly before I try that. There's definitely going to be several more episodes about this interesting DOS-compatible Performa, and I'm really looking forward to trying this thing out, because I think it is going to be a very useful and playful experience. Thank you so much for your time. Hope it wasn't wasted on this video. I apologize for this interruption. Special thanks to everybody who supports me on Patreon and on the YouTube channel memberships page and on Ko-fi. The links to that are in the video description if you consider giving me some support to buy some capacitor kits and things like that. I hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.